Our first example here, we want to solve the absolute value of x is less than or equal to 4 in interval notation, but we'll probably have to graph that on the number line in order to decide what that is. So I'm looking for all numbers whose distance from 0 is less than or equal to 4 units. So what might that look like? 1, 2, 3, 4. 1, 2, 3, 4. That's 4 units either way. And I want that distance to be equal and less. Well, a smaller distance from 0. 0 is no distance from 0, so that's less than that. And 1 unit is less than 4 units. 2 units is less. So, and those are just whole numbers. What about like half a unit distance? So all of these numbers between -4 and +4 are going to make this a true statement here. So our interval from least to greatest, or left to right, is going to be -4 to 4, including 4, because if I put that in here, right, that makes this a true statement. Yep. So that would be the solution set here in interval notation. So formally, how we're going to solve absolute value inequalities of this form where the absolute value is less than a number, if that's a positive number, right, positive number, then that's equivalent to saying what's in the absolute value is between the negative and positive of that number, because that's what we found for the distance. So this holds true for the less than or equal to as well. It doesn't matter if there's an equal to, as long as the less than symbol, the less distance is between the negative and positive. It's an intersection of values. So let's use this to solve inequality statements. Our first one here, the absolute value of x minus 2 is less than 1. So if that distance is less than 1, then that means that it is between a -1 and a +1. So this is our compound inequality intersection, and we just need to solve for x in the middle. So let's add 2 to all 3 sides here. So the left side, that's 1. The middle, that's just x. And the right side, that's 3. So this says that if x is a number between 1 and 3, not including because there's no equals to there, then this statement will be true. You want to check that to make sure. Okay, let's check 2 because that's between 1 and 3 for sure. There's a lot of numbers, but 2 is one of them. So if I put 2 in the statement here, then the distance from 0 is 0. Is that less than 1? Yep. And if you were to check anything outside of that solution space, those would not be true. So that means that our solution in interval notation from left to right is 1 to 3. Another example here, we have the absolute value of 2x minus 5 plus 2 is less than or equal to 9. But remember, I can't talk about distance, which is what the absolute value means, unless it's isolated, right? So I have to isolate that absolute value, which means I need to subtract 2 from both sides of this inequality so that I only have the absolute value on the left side. And 9 minus 2 is 7. Great. So the distance now I can talk about is less than or equal to 7 units. So that means everything from -7 to +7. So whatever is inside of the absolute value is between -7 and +7. Those will make this statement true. So let's go ahead and solve for the x in the middle. We need to first add 5 to all 3 sides. So the left side, that's -2. The middle, that's 2x. And the right, that's 12. And then we need to divide 2 to get just x in the middle. So left side is -1. Middle is x, and right side is 6. So this says, if x is any number between -1 and 6, including -1 and 6, because there is an equals to, whatever this symbol is here, we use that for both. So including both of those, we'll make the original statement here true. So let's check something that's in there. How about 0? So the absolute value of 2 times 0 minus 5, and then add 2, should be less than or equal to 9. So 0 minus 5 is -5, and that distance is 5 units, which means that 5 plus 2 is definitely less than or equal to 9. So that works out. So our solution in interval notation from left to right is -1 to 6. Theoretically, if a problem said that the absolute value of x is less than -2, what does that mean? So the distance from 0 to some number is less than -2 units. Okay, so how do I show a distance of -2? Again, I can't. There is no distance of -2, so how can I show what distance would be less than -2? A distance of -3? Oh, no. That doesn't work. -4? No. -500? That doesn't make sense. The distance can't be less than -2 because even -2 doesn't make sense. So any number less than -2 would be ridiculous. So that means there would be no solution to this type of inequality statement. And technically, if you wanted to set it up in a similar fashion, then x is between -2 and the opposite, which doesn't make sense, right? So if I set these up separately, looked at this as x is greater than 2 and x is less than -2, let's see what that would look like then. There's -2 and +2. So x is greater than 2 would look like that. And x is less than -2 would look like that. And means intersection, which this is. All compound inequalities are that are of this form are intersections. So where do these overlap? They don't, which is why there's no solution here. So then when we look at this next problem here, solve this absolute value less than -4, I'm going to say, hold up, negative number. How can the distance be less than -4? Can your distance be equal to -4.000000001? No, your distance can't be less than -4. It makes no sense. There's nothing to graph. There's no solution. And again, if you wanted to show that there's no way to show no solution in interval notation, but you can show it as an empty set, meaning there's nothing inside that set because there is no solution to this statement here. For number 5, we want to solve the absolute value less than or equal to 0. Okay, less than 0, I have a problem with because distance can't be less than 0. That means -0.000001. Whatever. I can't have a negative distance. It's not going to happen. So less than, I have a problem with. You can't say the distance is less than 0. But that's not all this says. This says or equal to. Can you have a distance of 0? Yeah. I didn't go anywhere. I have no distance. That's a 0 distance. That's fine. So that's what we're going to do. We're going to take the expression inside of the absolute value and say, yeah, you can have a distance of 0. That is 0. And then we'll solve this. So we need to distribute. That's 5x minus 15 over 2 equals 0. I can multiply 2 to both sides of the equation. because then that cancels out with that denominator there, leaving just the numerator, and 0 times anything is 0. So then I'm going to add 15 to both sides of the equal sign here, so that 5x equals 15. And then divide 5 from both sides of the equal sign to find that x equals 15 divided by 5, which is 3. So in this case, we find that there is exactly one solution to the inequality statement, where x is 3. So we show that on the graph with just a single point. X is 3. And can we write an interval? What values would be in that interval? Just 1. 1 is not an interval. 1 is a number. So if you have a finite amount of solutions, countable, I have just 1, then you can only represent that as a set. So the set where the solution is 3, and that's it. There's no such interval of 1 number. So that would be the answer to this inequality statement.